Hi, welcome to this course AI powered vehicle traffic monitoring project. So myself Mohammad Yaqub, I am the founder of Scratchlearn. He is Mr. Pandian, is senior AI developer at TensorFlow. When it comes to AI project into vehicle traffic monitoring, so it is essential for any city, for any government, it is essential for to get the data about the number of vehicle passing into specific area or specific zone. So that is the important data points for any governments to monitor and then manage the traffic in an efficient way. So in this project we will be using YOLO V8 architecture to detect the vehicles and then categorize it. Based on the categorization we'll be giving you the analytics, so that the government can take the insights about how many vehicles, what based on the category, based on the timing, went into specific zone, specific area, so that they can take the better decision and then they can manage the traffic in an efficient way. So let's dive into the project. So now Pawan will be taking over the project execution and explanation. Thank you.
I'm going to give a brief overview of the project, and the project is called the Vehicle Traffic Monitoring System. In this project, we will count the number of vehicles traveling on the road using the pre-trained YOLO weight algorithm. This algorithm is mainly used for object detection tasks, but in our case, we will specifically use it for detecting cars, trucks, and buses. Let's dive into the project code explanation as well as how to exit the code. First, you need to navigate to the Vehicle Traffic Monitoring System project folder. Then enter the command code in the command prompt and it will open the project in VS Code. Now VS Code is open. Make sure that all the necessary folders and files exist in the Vehicle Traffic Monitoring System folder. We have 3 sets of input videos: vehicle input 1, vehicle input 2, and vehicle input 3. Then there is the classes file which contains 80 classes for YOLO weight as well as requirements txt. There is also the sort folder which is used to assign a unique ID to each detected object using the IOA technique. And finally the vehicle monitoring file, Python file, then YOLO weight and the pre-trained model. First I'm going to explain the code for the project and then I'll show you how to run the code. To begin with, we need to import the necessary libraries required to implement the project. The packages include CV2, which is used for image processing and image handling. Then SORT is a technique used to assign a unique ID to each object. NumPy is used to handle RF data. Next is the YOLO weight model, which is used to detect objects within a frame. Then there's Tkinter. Tkinter is used to implement the graphical user interface. Then Tkinter file TTK, and these are used to display or frame content in a Tkinter window using the pillow library. Next, threading is used to enable multiprocessing. Sys is a basic Python library, and then there's time, which is used to download logs as a CSV file. Initially, the video path is set to none. The user has not selected any video. Then, after selecting a video file path, assign the video path to the video path variable. This is then used to choose your file in the Tkinter window using the file dialog. The file format should be MP4 or AVI. If the user has not selected any video file, then display an error. A video file must be chosen. Monitor traffic is a function and program execution begins from this function. At the start, we have some global variables such as the running total, vehicle count, car count, bus count, and truck count. Next, CV2 video capture is a function where you pass the video file into this function and it is stored in cap, which is used to access frames from the video. Then the YOLO weight model is loaded using Ultralytics. Then the class names are loaded and the tracker is initialized, which assigns a unique ID to each detected object, ensuring that each vehicle count is unique. We have used the set data type. Initially, the car count, bus count, and truck count are all set to 0. While running in a continuous loop, the frames are processed one after another until the end of the video. The capRead function is used to retrieve each frame from the video, and the frames are stored in the frame variable. It returns either true or false. If it is not true, then the execution stops, which means there are no more frames. Then the frame is displayed in a window with our specified input width and height. Next, the frames are passed into the model, which detects objects in each frame and outputs the coordinates, class name, and confidence score. Then this information is iterated through one by one. The info object retrieves the bounding box coordinates such as xzone, yone, x2, and y2. Then get the confidence score of your object. Then retrieve the class name and assign your class name as name. If the object is a car, truck, or bus, and the confidence score is at least 0.6, then we take this coordinate data xzone, yone, x2, y2, convert it into integers, store it in a NumPy array format, and then stack it. These pieces of information are then stored in a dictionary data type called detected vehicle. After that, the detected vehicle's information is passed into the tracker, which is used to assign a unique ID to each detected object, such as ID1, ID2, ID3. Then iterate through your data one by one in the tracker results, convert the object IDs into integers for each specific object, and then retrieve the values of zone, yon, x2, and y2. Initially, the vehicle type is set to none. Then iterate through your data one by one, which makes it easy to match the detected object ID with the object ID. Initially, we will process the data only if the vehicle information is present in the vehicle type, and then we will count the vehicles for each detected object, ensuring that only unique object IDs are allowed. If the same object ID is still present in the frame, it will not be counted again, and the same count will apply. Then log the vehicle, which provides some information in the Tkinter window, such as the object ID and the vehicle type. If the vehicle type is a car, then increase the count in your frame. And if the vehicle type is a bus, then increase the count. And if the vehicle is a truck, then increase the count. Then save it to a rectangle. This is a function used to draw a rectangle in your frame. For this, the coordinates yone, x2, y2 are used. This one is the color, which is green, and the thickness is 2. And then we need to pass the frame. And then CV2, which is used to draw text in your OpenCV window, we need to provide the frame. Then the ID, the location where the text should appear in your OpenCV window, the font name, the font thickness, and this is also the thickness, and this is the color, which is white. 255. 255 is actually white. This is the last pixel data, and then this is a function that is used to display a frame in your Tkinter window, such as the vehicle count, unique vehicle count, total vehicle count, as well as unique vehicle count. Then convert the frame from BZR to RGB, which will then be converted into an image format compatible with Tkinter. Only then will we be able to display it in your Tkinter window. Then, and this is a function that updates your data. And then finally, we need to release all the process frames and then destroy all CV2 windows. Log vehicle is a function designed to create another Tkinter window to display vehicle information here, such as the object ID, vehicle type, the position of the vehicle type, and the current time, all within the Tkinter window. Next, this is the timestamp, which is obtained by getting the current time and retrieving the value of the object ID for that specific data, then inserting the data into the log list and setting the total vehicle count. The program then starts from this function, start monitoring. First, the user needs to select start, and if it is not selected and you want to use a video file, then we should display a notification to them. Please select your video file first, and if you want to quit the program, you can do so using the exit button. You can also download the log data in CSV file format, and the user needs to select the folder path. Next, we define the Tkinter window with the window name set as Vehicle Traffic Monitoring System. The Tkinter window size is 1024 by 600 and the window is resizable. Then this configuration is used to create a heading as well as to carefully insert your button label into the Tkinter window within your application interface. TTK notebook is a function used to create multiple Tkinter windows. The first window is named monitoring and the second window is named logs. Then there is a video selection frame which initially shows no file selected. First, the user needs to select their video file by choosing a file. We have a button for this and the background is black. The vehicle traffic monitoring system is displayed here. This is the overall main title of the Tkinter window. After that, video frames are then passed into this label in order to display a frame which is specifically used to monitor your tab. It also displays in real time the number of vehicles traveling on the road, such as the vehicle count variable and also the counts for cars, buses as well as trucks. And then this label is used to display your total number of vehicles as well as the number of cars, buses and trucks. The log list frame is another Tkinter tab that displays the object ID, vehicle type and timestamp. Finally, there are log buttons that are packed and this information can be downloaded as a CSV file. Then the button is also packed, and finally we have two buttons. One is the start button and the other is the stop button. Finally, route main loop keeps the Tkinter window running until we stop the program. This is the code explanation for the project. Next, we are going to see how to run the code. First, we simply need to open the terminal, a new terminal, and first we need to install the Ultralytics library. Pip install R requirements txt. Now Ultralytics is installing and it has been successfully installed on my machine. Then I'm going to run the vehicle traffic monitoring system code. CLS, then Python monitor, py file, then press enter. The program execution has started successfully and the Tkinter window has also opened. First, I'm going to choose a video file. And this is the video file. First, input the video, then press enter. Then I'm going to click start. A car is detected with ID 1 and the total vehicle count is 1 as expected. The car count is also 1. The second car is also detected with object ID 2. So the total vehicle count is 2 and the car count is 2. And now the third car is detected. Then the total vehicle count is 3 and the car count is 3. and the fourth car is detected. The total vehicle count is 4 and the car count is 4. Another truck is detected with ID 5 and the total count increases to 6 with one truck. Now another car is detected, so the count is 5. The total vehicle count is 6. To provide another set of input videos, we need to run the program from scratch. And now the Tkinter window is open and I'm going to choose a video file, another set of input videos, vehicle to input as well. Then start. The model inference has started. The total number of cars detected is 6. And now it's 7. And then 8. Now 10 cars have been detected. Now one truck is detected, and then the total number of cars detected is 16 and the total number of vehicles is 17. A total of 25 vehicles are detected with 24 cars and one truck. Then I'm going to show the log information. And here you can see the object ID, type of vehicle, and detection time. Next, I'm going to download the logs. Car input to the system is received. The file is in CSV format, then save it. Finally, I'm going to stop the execution. I hope you were able to understand everything in my explanation of the project and how to run the code. And if you have any questions about the project or the code explanation, please leave your questions in the comment section. I am ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely will help you in as soon as possible in a better way. Thank you.